Right, okay, starting with queue. Queue functions. It is a first in, first out system, just like a human queue. You join at the end and you leave from the front. Implement using an array linked list. And requires 2 pointers if you're doing it using an array. So 2 pointers required. You need a front and a back, but the exam board in their questions, they might use different, they might say front end, start, back, you know, they'll mix it all up, but go with whatever they decide to call them. Remember, they may flick a queue round, so the front might be at the right, the back might be on the left, so just read the question carefully.
Does the back pointer point to the last item in the queue or the last free space?
If you're doing it sensibly, it will point to the free space, but that's not set in stone. You don't have to create a queue like that. You could make the queue point to the last item, and then when you add a new item, you increase it first. But go with whatever diagram they show you. They'll give you an example in the diagram. All right, yeah. So just to illustrate that, Zion. So you might have a situation where, well, I'm not going to do many things in it. Right, so that's my queue. So I'm going to call queue. And I might have 3 things in it. So you might have your front pointer there, and if I was coding it, I would put the end pointer there. So it's always just like so like in a stack, it points at the next space, doesn't it? Yeah. But the exam board could, if they really, really wanted to, they could mark the end like that. You'll find that out. So that's front is always pointing at the first item. That's not an issue. So this slight complication is going to be dependent on question. So basically, it's that standard read the bloody question sort of thing, isn't it? But the algorithmic thing is essentially the same, apart from you might need to increase the endpoint first. So let's have a look at onQ and DQ then. So let's go back to, I'll go back to black so it keeps the contrast high. Right, so onQ. So let's do that. Right, okay, it needs a parameter. What the hell are we going to add? So we'll call the item, but obviously the exam board will, if they give you any code, they'll obfuscate it, won't they? They'll try and make it. Just as a heads up to everybody, I know it's on my video, I don't care. Marking the year 12 tests, you know when they say, oh, trace this algorithm and say the output, and then they always follow that up with, so what does this thing do? They want you to look at the inputs and outputs, don't they, and say, what do you think was the relationship between them? So, like, was it rounding up, or was it doing the multiples, or whatever it is? And they'll do that with Little Man, and they'll do it with normal algorithms. Please, please, please don't look at the names they've given the variables and try and guess what the algorithm was doing. Because they pick really daft names for things. I've had a load of year 12s, I've looked at, there was an algorithm and it was just doing some basic thing. It was printing out every element of a linked list. That's what the purpose of it was, in order. And one of the, it used a while loop, and they had the thing that controlled the while loop was called finished. So they said it does things until it's finished. It's searching, and it's like, what are you talking about? The purpose isn't how it works. The purpose is what is it attempting to do. All right, so please don't drop into that hole. Right, okay, so on Q, let me scroll that up a little bit. We need to check to see if we've got a viable queue. So we need to see if the queue's empty. So depending on how this queue works, if we've just got a standard linear queue, a buffer, if the end pointer, and it always helps you remember to write down the indexes of an array and also its length. So that's length 6. So if this was full, and do yourself a little example, so, okay, what won't do it? End would be here, would be 6. So we can do for this specific one, we can say, right, well, if the end, I'll use end, if that is equal to the length of the queue, then it's going to be full. Okay? We don't care who was using this queue. We're just a queue. We don't know about the big context of the world, so we just say full. So you're going to say queue full. We don't necessarily do a print unless they specifically say in the question, oh, it outputs an error message, then you can do a print. But I'm just going to put an indicator and say, right, if that logic statement is true, then the queue's full. Got to check for queue full, queue empty in the right place, obviously. Right, okay, so I'm then going to say, well, actually, if it isn't full, let's attempt to add this item. So I'll do this in the two different ways. I'll do it in blue and black. So if it's the end pointer is pointing to the next free space, then what I can just do is say queue, oops, I don't like this word, I can't spell it. Queue at end equals, and we're just going to store the item in there, and then I need to update the pointer. I'm not going to check to see if it's full. That's not the job of this part of the algorithm. All right, that's the start of the algorithm, so I don't care. So I'm just going to say end plus plus. I would hope every single examiner knows what end plus plus means. If in doubt, you could put end plus equals 1 or something. If they don't understand that, well, I'll give up. Right, so that takes account. So that's if the end pointer is at the free space. Okay. Right, okay, so let's assume it's the other way round. So in this case, if it was full, it would be pointing here, wouldn't it? So that would be the full condition. So I'll have to do it below because I've gone across many things. Right, so I'm going to do the same function, but I'm going to change the colour. So I'm going to say func on queue. So my full condition is slightly different. Okay. So that would be full if end was pointing at the last available position. So, and the reason why I always use an X3 space because it makes the logic easier to read as well. But what I will put then, same structure, I'm still going to test. So I'm going to say if end is equal to len of the queue minus 1. I mean, it isn't any harder, it's just not as easy to read. I don't think. When you have to start doing minus 1s all over the place. And that's going to be the same thing queue full. And the other logical change we need to make, when we go to store the item, we need to make sure we increase the end pointer first. So we say end plus plus, then we write the item. So you've just got to be careful about how they've organised the end pointer, because it alters the sequence you do things, that's all. So that's on queue. Right, when we remove things, it's the front pointer we mess about with. Okay, so let's go back to black pen. And we call that DQ. But they have a problem. If they ask a question where they want you to name what these functions are called, they'll try and obfuscate. And they might say push and pop and things like that, and they have done in the past. Okay? So that they don't give you the answer to another bit of the question, which is a bit stupid, really. But there you go. Right. So with DQ, we want to remove something from the stack. We do not need a parameter because we remove whatever's on the stack. So just looking back at our little array, the front pointer points to the front of the stack, front of the queue. So that's where we're going to retrieve the item from. What is going to be the value that tells us that the queue is empty?
If the front and pointers are overlapping.
Yeah, now this is an issue. So you need to think about this, and you'll need to, like, if you got it in head, and you know what, I can't remember stuff, so I'm just going to do a little test for myself. So just going to really quick on this. All right, well, let's make the smallest queue I can make. 3 items. I'm going to put the front pointer there, and I'm going to put the end pointer there. So this is, and I'm going to use the my system. All right, so I've got A and X. Right. Okay. So the queue's not empty. I'm then going to read, so that moves the front pointer along. So the queue's got 1 item in it. If I read DQ that, they're going to be equal. Yeah, so if the front and end pointers are equal, it looks like, now that's not necessarily true, it looks like it's empty. Let's do an empty queue and see where the pointers might sit. It's all about examples. Right, so that's where I'm going to put the front. Well, if I'm using my system where end points to the free space, it's going to go there. So in that system, if the front and end pointer are the same, then it's full. If you get completely confused and stuff, just put if queue empty and leave it at that and carry on with the logic. Okay? It's pseudocode. Unless they say specifically how can you test for empty. And do you know what I'd do if I got, and I was like, I can't remember this. I'd say every time I add an item to the queue, I count. Every time I remove an item, I would uncount. Increment and decrement. Why not? There's no one way of doing this. So yeah, try and cover yourself. Right, so I'm going to go with that as my test. So I need to do that first. So I'm just going to say if front is equal to end, then that's going to be full. Not full, yeah. So Q empty, and obviously if it's empty we can't return anything. This is pseudocode. In a lot of languages, if we don't return something, it'll go doolally at us and say, oh, you can't do that. But it's pseudocode. I'm just showing the intent. It's up to the programmer. The funny thing is, if you're doing it in Python, you don't have to do return, do you? Python's a bit weird. Yeah, I mean, what we do is we give some, in reality, what you might do is throw an exception. You know, if you was doing it properly, so that someone can then say, oh, queue empty exception, I'll deal with that and do something else. Whatever that is. Depends on what they're using the queue for. Right, okay, so assuming the queue isn't empty, we want to return the item at the front. So let's grab the item. This is the safe way of doing it. So we just say queue at the front. The key thing they want to see you doing is you using the right pointer. Remember, if they want to try and get you to look at logic errors, they might use the wrong pointer and give you an algorithm and say DQ from the end or something like that. Right, so once we've done that, we need to increase the front pointer and then we can return that item. You can be clever and write it all in one line, but I wouldn't advise it, just in case. Okay, right, let's just explore what happens if you make the end pointer point to the last item. Okay, which is why I don't like that method. So, assuming we go with that other system, so let's have a look, let's put the queue into the state with the A and X in it. So front is there, end is there in that system. Right, let's remove the A. So that's not empty this time, is it? If I remove the X, the front pointer goes there. Remember, when we do in DQ, we don't touch the end pointer. So actually, potentially, it looks like the front pointer is beyond the end. Okay. Now let's just have a look at what we did when we on-queued in that system. We increased the pointer first. So actually, if we've got an empty queue, there's never been anything in it, front is going to be pointing there, end is going to be pointing there. So you could just do it. I'm not going to write the algorithm out again. Alright, so you just have to be careful about it. The easiest way is to do count. Because the user might want to know how many items are in the queue, and you don't have to be subtracting numbers and things to create a count. It's easier to say, you know, in here, whenever I add, if I genuinely do remove something, I could just put something in there saying, oh, like count minus minus, and whenever I add something, assuming I have added something, I can just say count plus plus. And in reality, that's what you're doing. In reality, that's what you would do if you wanted it to work efficiently. Yeah, so if you're going to do a circular queue, you want both the front and end pointers to wrap, don't you? And in that case, the logic doesn't work for the front and end counting. Okay, so if you're doing a circular queue, so where you do this bit, it doesn't matter which pointer you're doing. So if I go front plus plus, then I can do this. Right, so if I do a little example again, and I just go, so that's 0, that's 1, that's 2. So if it becomes 3, the length of the queue, we need to go back to 0, don't we? So you can do it a few ways. You can say if front equals queue.length, or whatever the thing you're going to use for your pseudocode, then you can say front equals 0. Or you can do the mod system. So you can say front plus plus, and then you can say front equals front mod, and I would always write mod, not put a percent, just to make sure. And then it's going to be the length of the queue again, isn't it? And if you want to be really clever, you could do it like this. You could say front equals front plus plus mod, and you don't have to do a test at all. Right. As a side question, I'm using mod. What is the major benefit of using mod than an if? If we're talking about big O notation, time stuff. The space stuff is stupid, I don't know why that's matter. What's the difference? Yeah, so what would you describe the mod version as? In big O. There is one of the algorithms that we've looked at is the same big O. And it involved a calculation. What algorithm we looked at that is a calculation-based algorithm that has a really interesting big O? Now. It is a search algorithm. Well, it's not really a search algorithm, but it's used for searching when you want to do it the quickest way possible. What's the quickest way of searching for an individual item?
Hash table.
Yes. What's the big O for accessing a hash table? Constant. Because it is just calculation, isn't it? So, this is going to be a constant. Because you're doing just some maths. This one isn't. Sometimes you'll do the if, sometimes you won't do the if. So, you've got time differences. Whether that matters or not when you're messing about with a cube depends on the situation. In general terms, it shouldn't, but it might be if you're doing a time critical process. So you might prefer this one. You can do mod really clever if you've got powers of 2, because you can just do masks, which someone asked me about masks. Okay. Right, any other questions about queues? You've got to read the question. Queue's the one that can screw you up.
Do they make you implement a circular queue?
They haven't, they did, I think there was one of the past questions where they said, what would you need to do to implement a circular queue? So it is just about this, saying wrap it round and do a keep account of how many items so that you can tell whether it's full or empty.
The only ones you need to know the standard ones.
Yeah, standard ones, generally. Bearing in mind though, they could be sneaky and make it part of the, here's a process, can you write some code for that process? So they could describe how a circular queue works, couldn't they, technically? It's odd, it used to be what we taught. We used to teach circular queues, and this, like, buffer version where it's like, oh, once you get to the end, you've got to wait for it all to be cleared. Used to be a naff way of doing a queue, but they got rid of that, I don't know why. So there you go. Right, okay, I'll stop that one recording so I don't put too much in one go.